So there are three concrete classes that implement the set interface inside of our collections framework. The third of those would be TreeSet. The other ones are linked HashSet and HashSet. So I'd like to look at the third and final concrete class that implements set. So a quick overview of this particular slide deck is we'll have an introduction of what is a TreeSet. We'll look at the TreeSet class declarations. We'll look at the hierarchy of the TreeSet class in Java. We'll talk about the features of TreeSet and the constructors and the methods that are worth mentioning. And so TreeSet's unique in the fact that it's not like HashSet and it's not like linked HashSet. There's more methods because of it's where its hierarchy comes from. So we'll take a look at the sorted interface and the navigable interface. And then we'll look at some examples using TreeSet. And then we'll look at actually being able to sort on a TreeSet. So here we have some sorting options. And then we'll talk about when we might want to use a TreeSet and then a HashSet versus a TreeSet, when you might want to use one versus the other. So a quick introduction here is a TreeSet in Java is another important implementation of the set interface. It's similar to the HashSet class with one added improvement. It sorts elements in ascending order while the HashSet does not maintain any order. So HashSet is a unordered collection. The linked HashSet is an ordered collection based off of insert. The TreeSet is an ordered collection that actually sorts based off of ordering. So if it was numbers, it would order it in an ascending order. So it'd be like 1, 2, 3, 4, 5, 6, right? It would, and even if we put that outside of that order, it's not the insertion order. So if I put those in reverse order, 5, 4, 3, 2, 1, TreeSet would then have it as 1, 2, 3, 4, 5. TreeSet implements SortedSet interface. It is a collection for storing a set of unique elements according to their natural ordering. It creates a sorted collection that uses a tree-based structure for the storage of elements or objects. So in simple words, elements are kept in a sorted ascending order inside the TreeSet. So as an analogy, imagine if you had like a set of books which you might want to keep by height or alphabetically by title and author. In TreeSet, access and retrieval of elements is fast because of its tree structure. And we won't go into too much detail as to why trees are so quick at accessing elements. Just understand that's what that is the case. And you'll learn more as to why that's the case in the next class in data structures. But knowing that trees allow quick and rapid access and retrieval of elements, having the TreeSet use a tree is an excellent choice for quick and fast access to large amounts of sorted data. So the only restriction with using TreeSet is that you cannot add duplicate elements in the TreeSet, right? Because it's a set. That's a common theme across all sets. So the class declaration in the set is that the class TreeSet, and it's a generic class, extends the abstract set and it implements the navigable set. So if I want to look at this hierarchy, we have the TreeSet here, which extends the abstract set class, and it implements the navigable set class, which itself extends the sorted set interface. I'm sorry, the navigable set interface. It implements that, and which itself extends the sorted set interface, and which extends the set interface. And of course, they're all members of the collection data type. So that's like the mother type of all of these in our collection framework. And so some features of the TreeSet that are important to kind of recall and understand is that a TreeSet contains unique elements similar to the HashSet. It does not insert duplicate elements. The access and retrieval times are quite fast. The TreeSet does not allow inserting null elements. So that's where there's a big distinction between TreeSet and the HashSet and the linked HashSet. They allow at least one null element. You can't have any null elements in the TreeSet. And the reason behind that is null elements, it doesn't make sense for sorting, right? There's no sort order. It breaks the sorting concept that TreeSets ensure. The TreeSet class is not synchronized, which means it's not thread safe. Notice none of these have been. This is, and we'll talk more about that when we start talking about multi-threaded applications. TreeSet maintains the ascending order. So when we add elements into the collection in any order, the values are automatically presented in a sorted ascending order. And the Java TreeSet internally uses a tree map for storing elements. And again, we'll talk more about maps in the next upcoming lectures. That's the next type of data type or data container collection that we're going to be interested in learning about. Okay, let's talk about the constructors of the concrete class TreeSet. Well, there's a default constructor, and again, it's generic, so we can pass the type inside of angled brackets. And really, we don't really need to do that. Perfect. We can pass in a collection. This is true. This should be true for every concrete class in our collection framework. So we can take one collection and easily translate it into a tree set. And if we do this, it will create a tree set, well, that will then have the natural ordering of all the elements. And is going to use, in order to order the elements, it's going to use the comparable interface. So all of the elements inside of the collection has to know how you can compare one element to the other for the purposes of sorting. And so if the collection C element does not implement the comparable interface, then you will get a exception thrown from the constructor, the class cast exception, because you can't cast something into an ordered collection if there's no defined way to sort on the individual elements. So what this means in practice is that, like, for instance, integer automatically implements, the integer class automatically implements the comparable interface so that you can compare one integer value to another. String automatically implements the comparable interface for us to be able to compare one string to another. If you built your own user-defined object classes and you wanted to put them in a tree set so that they can be automatically ordered, you would have to have your object, your class, implement the comparable interface, and alongside that, the abstract method that would allow you to be able to define a natural ordering on your user-defined class based off of how you think it would be ordered. So say, for instance, you're building a, I don't know, a monster class, and you want to be able to sort the monsters, and maybe maybe the idea behind what it means to sort monsters is based off of the level of the monster, and that could be stored as a numerical thing. Then you would implement the comparable interface, and the method that you would implement for your sorting would then probably use its instance variable level for that. If a collection C contains a null reference, the constructor will then throw a null pointer exception. Okay. We can also instantiate a tree set with a comparator object. So this constructor creates an empty set that will be sorted according to the comparator object specified by that you will then add in. So then it will do the ordering based off of this comparator instance. So all elements in the tree set are compared mutually by the specified comparator. A comparator is an interface that is used to implement the ordering of data. We can go ahead and use SortedSet. So recall that SortedSet is an interface that TreeSet implements. So it has a constructor that allows you to pass in another data type of SortedSet to build a tree set from that. And so some methods that are worth looking at from TreeSet. Let's take, a lot of these are common, but we'll look at some that aren't. So these are the just TreeSet methods. So the ability to add into our tree set. And again, it returns whether it was true or false, whether it was successful or not. We have add all, where you can pass in a collection and it's going to return whether it was successful or not. You can clear all the elements from a tree set. You can find out if the tree set is empty or not. You can remove elements from a tree set and it'll report back whether it was successful or not. You can check to see if the tree set contains a particular object and it returns back true or false, whether it does or not. You can check the current size of TreeSet. You can request an iterator on your TreeSet so you can walk through it, and it'll iterate the elements in ascending order, right? Because remember, it's sorted. There's a split iterator as well. The split iterator method is used to create a late binding and fail fast iterator over the elements. We have the ability to clone. So this will give us a shallow copy of our TreeSet instance. And then we have a descending iterator that's used to iterate the elements in descending order as opposed to ascending order, right? So essentially that's like the going backwards across the TreeSet. Okay, so there are more methods in TreeSet than just the common ones you would expect from the other sets, right? Here we also have the SortedSet interface. And so since TreeSet implements SortedSet interface, all the methods defined by the SortedSet interface can be used while using the TreeSet class. So here we can go ahead and get the first object inside of our TreeSet. That would be the lowest element. We can get the last object, which is supposed to represent the highest element or the last one in our TreeSet. We can go ahead and get a comparator. So this returns a comparator that's used in order for the elements in the set. So the TreeSet uses the natural ordering. And so it uses the comparator to be able to compare the objects. Head set, where we pass in an object. This method returns the collection of elements that are less than the specified element. So if you pass an object in here, it'll give you everything that's effectively to the left side if you go from lowest to highest from where that appears inside the collection. So subset, and then you pass in two parameters, the from element object and the to element object. So this is going to return a set that lies between the given range. So you can give a low value and then a high value, and it'll give you everything in between. So again, going to our example of if you had a tree set of monsters, and monsters are kind of ordered by their levels, you can say, give me the collection of all monsters that are between effectively this first this monster that's like a level 2 monster and this other monster that's a level 5 monster, and then it'll give you all the monsters in between, and then maybe you might randomly select one and then use that, spawn that inside of your game so that you can have like level zones, for instance. Just try to give you an idea of how you might use this inside of application. And then just like you have head set and subset, you also have a tail set, which will return the element of a set that is greater than or equal to the specified element. So give me all the highest level monsters. So if I pass in like a particular monster at like level 8, it'll give me level 8 or anything higher. Okay, we talked about the sorted set, those methods that we get from the sorted set interface. Let's talk about those methods we get from the navigable set interface. Since again, the TreeSet implements the navigable set interface, we get all the methods of this interface. So here, this would be ceiling, floor, lower, higher, and pull first. So ceiling returns the lowest element from the set equal to or greater than the specified element. And if there's no such element, then it returns null. Floor will return the greatest element from the set equal to or less than the specified element. And if it doesn't exist, it's going to return back null. This is why null is not can't be a value, right? We're using null as a value of when we fail to find something. We also have lower and higher. So lower is a method that returns the largest element from the set strictly less than the specified element, as opposed to less than or equal to. And then higher is along the same lines. This will return the smallest element strictly greater than the specified element. And if no such element is found, it will return none, a null. Pull first is used to remove and retrieve the first element of the tree, right? So this actually removes it. So this mutates the state of your tree. Pull last is used to remove and retrieve the last element of the tree set. So this will remove that element. So descending set returns back a navigable set object. And so this method returns elements in reverse order. Head set is a method that returns the collection of elements that are less than or equal to it. And again, that gives you a navigable set. And then again, we have subset and tail set, but these are returning them in the form of navigable set collections as opposed to sorted set. So, but the behavior is very similar. Okay, let's take a look at some actual examples of TreeSet in terms of code. Suppose we wanted to add elements. Let's create a program where we will perform different operations such as adding, checking the size of TreeSet, the set, whether the set is empty or not. So let's jump really briefly here to our IDE. And here we're looking at our TreeSet tester. And here I'm going to import the set interface. We're going to import TreeSet concrete class. We're going to create a class TreeSet tester 1. We're going to have a main method in here. Here we're going to create a set variable that's going to hold strings, and we're going to instantiate into it a new TreeSet to illustrate, hey, this is a concrete class of set. Then we're going to say, hey, let's check if it's empty and print out that state. We're going to check its size and print out the size. We're going to add in elements, right? Some strings of various countries. Then we're going to print out the state of our sorted set and our size. And then we're going to take a look. Let's go ahead and run that. Okay, is TreeSet empty? It is. The size, initial size is 0. Now, when we look at our sorted TreeSet, look, we put this in a random order, but the order we're getting back has been alphabetized. Australia, India, New Zealand, Switzerland, USA. Because strings automatically have a comparator that uses alphabetical ordering, and this is ascending order. And the size of our TreeSet is 5. Also for here, let me close out these to make this perfect. Okay. So let's look at let's make a program where we'll perform operations that remove elements. So again, this is relatively simple. We've seen how to do this in other sets. So it's going to be similar to that. We're going to import our TreeSet package. TreeSet class. We're going to create a class of our own to test this. It's going to have a main method here. We're going to create a TreeSet variable that's going to hold strings. We're going to add our countries into it. We're going to then find out if our TreeSet contains USA, and we're going to print out that Boolean response. Then we're going to remove New Zealand, and then we're going to print out the new state of our sorted TreeSet. Then we're going to clear our TreeSet, and we're going to show what the state of our TreeSet there is. So let me go ahead and run that. And here we can say, is USA in TreeSet? Well, yes, it is. Then our sorted TreeSet is going to be Australia, India, Switzerland, and USA. Notice it removed New Zealand. And when it removed New Zealand, it maintained the alphabetical ordering. And then when we clear the elements out of TreeSet, notice there's no elements in there whatsoever anymore. Okay, let's talk about the SortedSet methods. So now we will make a program to perform some different operations based off the methods that were defined in our SortedSet interface. So let's take a look at this source code. Let's jump over here. Here we're going to import our HashSet. We're going to import our set interface. We're going to import the SortedSet interface. We're going to import the concrete class TreeSet. We're going to create a class TreeSet tester 3. It's going to have a main method. Here I'm going to create a new variable of data type set that holds strings, and we're going to add some elements into it. And so this set is going to be of data type HashSet. So we're using a HashSet, which is an unordered set, right? And so we have Delhi, we had Delhi, so that's duplicated, but because it's in a HashSet, that will get ignored. Then we're going to create a new empty TreeSet. Well, not empty, because what we're doing is we're passing in a collection in there. So we're going to create a new TreeSet, and we're going to pass in our HashSet into it, which is now going to convert it into a sorted tree, right? And then what we'll do is we're going to start using some of those methods in there. So we'll find out what the first element is, what the last element is. We'll do the head set using London. We'll use the tail set using London. We'll get the subset using from Delhi to Paris, and we'll print that out. And then we'll also just print out the comparator that we'll get from there. So let's go ahead and run that and take a look. So here our sorted set is Delhi, London, New York, and Paris. Notice it's in alphabetical order. The first element is going to be Delhi. The last element is going to be Paris. Going here, the headset from London is going to be Delhi. Yep, the thing in front of that from London is going to be Delhi. Let's see, the tail set using London is going to be London, New York, and Paris. So that is inclusive of that and everything to the right of it. The subset between Delhi and Paris is going to be Delhi, London, New York. Notice it's exclusive of the to object, but it's inclusive of the from object when we pass in to get a subset. And then our comparator here, let's see, is going to return sorted set is going to return null. And the reason why it returns null is because natural ordering is used. Excellent. And then I want to look at some of the navigable set methods that we've discussed. So let's make a quick example program where we perform operations based off of the navigable set interface. And so here, let me just quickly open up the source code file. Here, I'm going to import the TreeSet concrete class. Here, I'm going to create a class of my own. I'm going to create a main method. I'm going to create a variable of TreeSet. And I'm going to instantiate it, and it's going to hold integers. I'm going to add some integers, 25, 80, 5, 100, 90, 200, 300. Now I'm going to print out the state of TreeSet so we could see that it's now numerically ordered. Then I want to call some of these methods. I'll get the lower, ts.lower. This is the largest element, less than 100. Then I'll do ts higher. This will be the smallest element greater than 100. So it's the largest element that's on the left side of 100, and this is going to be the smallest element that's on the right side of 100. Then I'll get the floor of 85. I'll get the ceiling of 10, and then we'll do a pull first where we actually remove the first element, and then a pull last where we actually remove and retrieve the last element, and we'll print that out. And then we'll take a look at the new state after we do the pulls, first and last, pull first and pull last. Then we'll also go ahead and get the head set. So we'll between these elements from 90 and inclusive. So we have the option whether we want to include that element or not, as well as the subset. And we can make that inclusive as well. So we can use 4 parameters. So from 90, and we want it to be inclusive, true, and then to this element, to 200, and we want that to be inclusive, which means include that and don't omit the edge cases there. So if I go ahead and run this, you will see our sorted set. It sorts it 5, 25, 80, 90, 100, 200, and 300. Perfect. The largest element that's less than 100 is 90, right? And that's right to the left of here. The small, and that we got that using lower. The smallest element greater than 100 is 200, right? That's the first element that appears to the right of our value that we pass in here. That's the higher method. Here, the floor of 85 is 80. And here, notice 85 isn't in there. So if we're looking for the next smallest value that we're passed in, then that's going to be 80 since 85 doesn't exist. And the ceiling of 100, now 100 doesn't exist, but the next highest value of that would be inside of our set would be 25. So notice using these, we can pass in any value and it'll grab us the next thing that's close to it, either lower or higher. Pull first is going to remove the first element, 5, from our set. Pull last is going to remove the last element from the set. That's going to be 300 here. Yep. We're going to look at how our set has mutated after those pulls. So notice we're now missing the 5 and the 300. So it's now 25, 80, 90, 100, and 200. The head set, where we pass in a element and we want it to be inclusive, is going to return 25, 80, and 90. So it's going to return everything to the left, everything that's smaller than 90, and it's going to include 90 in that set. And then the subset is going to be between 90 and 200, and we want to include 90 and 200, so we're going to get the subset of that, which is going to be 90, 100, and 200. That's this right here. So we do lots of cool, interesting things with the tree set. And then the last example I want to illustrate is how we can easily iterate a tree set. And we're going to use both the Iterator method in ascending and descending order. And so let's just take a quick look at the source code here. And so here I'm going to import the Iterator interface. I'm going to go ahead and import the TreeSet concrete class. I'm going to create a class of my own. I'm going to create a main method. I'm going to create a variable of data type TreeSet that holds integers. I'm going to hold some integers in there, 25, 80, 5, 190. Then from my TreeSet, I'm going to invoke the Iterator method, and I'm going to store the Iterator method that's going to return back integers. And then I'm going to iterate. While my iterator has next, I will go ahead and print the next element. And then if I want to go ahead and do this in reverse order, I can go ahead for my TreeSet. Remember, I had that descending iterator method I could call as well. So I'll call that, and descending iterator returns back an iterator. So these are both iterator objects. It's just one iterator's cursor starts at the beginning of the TreeSet, and the other one is at the end of the TreeSet, and it will move backwards. So as each iterator has next, it'll go in a descending order. So we will then have the cursor print out from the iterator for each next value it has. So again, if I go ahead and run this code, you can see from the normal iterator method, I will iterate 5, 25, 80, 90, 100. And then from the descending iterator method, I'll go from 100, 90, 80, 25, and 5. Excellent. So a TreeSet sorts the natural ordering of elements when it implements the java.lang comparable interface. That's how it works. The ordering produced by comparable interface is called natural ordering. The syntax is given as this. So comparable is an interface, and inside of comparable is an abstract method compare to that takes in some object. So anything that implements the interface comparable so that you can use it for sorting must implement this compare to method. And so the compare to method takes in another object, and it returns back either a 0 or a minus value or a positive value. And that value, because it's an int value that returns, lets you know whether it's smaller, it's larger, or it's the same. Right? If it's 0, it's the same, and if it's a plus, it's larger. If it's a minus, it's a smaller value. So the TreeSet in Java also determines the order of elements by implementing the Comparator Interface. This technique is used when TreeSet class needs to impose a different sorting algorithm regardless of the natural ordering of elements. The Comparator Interface produces two methods in which compare method is more important. The syntax is as follows. So here we have public interface comparator. Here you have the compare, where you can compare two things. It's an abstract method. And you also have the equals, where you pass something and it determines whether it's equal or not. The compare method of the interface accepts two objects, because the point of a comparable object is to take in two things and return back that int value, either 0 or minus value or positive value, to determine whether something is greater or larger or the same. And there's also a Boolean whether they are equal or not, which would. So when would we use TreeSet in Java? Well, TreeSet can be used when we want unique elements in a sorted order. And so which is better to use, HashSet or TreeSet? Well, if you want to store unique elements in sorted order, then obviously use TreeSet. Otherwise, use HashSet when ordering isn't required, because again, HashSet is much faster than TreeSet. HashSet is the most optimized, but it also doesn't have any ordering. So if ordering matters, then you want to use TreeSet. And if insertion order matters, then you'll use linked HashSet. But those are the three concrete classes of sets, and that's when you'd want to use each one of them. Okay, excellent. We are done with sets entirely. Is there any questions about what we covered in today's lecture? Okay, I will end the recording, and I'll just go ahead and say